Hello, everyone, and welcome. I am really excited for today's session. Today, we are going to learn Python from absolute zero. No experience required, no jargon, no confusion, just clear, simple steps. By the end of this session, you will understand what Python is and why people love it, how to set it up on your computer, and how to write your very first line of code. We will cover variables, loops, functions, data structures, say the complete foundation. Everything we go through today is what professional programmers use every single day. So let's dive straight in. First question, why Python? Of all the programming languages out there, why should you learn this one? Number one, Python is a beginner friendly, and unlike many programming languages that look like alien code, Python reads almost like plain English. The syntax, that means the grammar rules of the language, is clean and minimal. This means you spend more time thinking about solving problems, less time fighting the language itself. Number two, Python is extremely versatile. You can use it to build websites, to analyze data, to create AI models, automate repetitive tasks, write games, build APIs, and the list goes on and on. One language, unlimited possibilities. Number three, Python has a massive global community. If you ever get stuck, and you will, every programmer does, there are millions of developers online who have already solved your exact problems, and you are never alone. So, the fourth is because of the career opportunities. Python consistently ranks as one of the highest paying programming languages in the world. Companies like Google, NASA, Netflix, Instagram, Dropbox, and Spotify use Python in their products. So whether you want to build something cool, switch careers, or just understand how technology works, Python is the perfect starting point. Before we can write any Python code, we need to install it. Don't worry. This takes about 5 minutes and we only do it once. So step 1, go to Python official website and download the latest version. And version 2 or Python 2 is no longer supported, so make sure you pick the right version for your operating system, if it's Windows, MacBook or Linux. So step 2, you run the installer. Now, here is a very important detail for the Windows users. Before you click install, make sure you tick the checkbox that says Add Python Path. It's at the bottom of the installer window, and if you miss this step, Python won't work from your terminal. So step 3, we need to verify that it worked. And you open your terminal, that's command prompt on Windows, or terminal on Mac or Linux, and type Python --version. If you see something like Python 3.12.0, you're good to go. Now step 4, we need to choose our code editor. Think of this as your writing desk. It's where you will write all your Python code. My recommendation for this absolute beginner is VS Code. It's what I've been using. Simple, it's free, and incredibly powerful. Feel free to choose the code editor that you're actually conversant with. Now, alright, Python is now installed, and now let's write the code. By tradition, the very first program every programmer writes says, "Hello world." It's a rite of passage, and in Python, it takes exactly one line. So here it is, print then in brackets, open quote, hello world, close quote, close brackets. That's it, one line. The print function is one of the most used tools in Python. Whatever you put inside those brackets gets displayed on the screen. So it could be words, it could be numbers, results of calculations, etc. And here is what you see when you run it. Hello world. Beautiful, right? Let's look at the key concept on the right. Text always goes inside quotes, either single quotes or double quotes. Both works. Numbers don't need quotes, and see this hash symbol? That's a comment. A note for humans that Python completely ignores when running the code. So add one more thing. Python reads your code from the top to bottom, one line at a time. Simple, predictable, and logical. Now, we go to one of the most fundamental concepts in all of programming: variables. A variable is simply a container that holds a piece of data. Think of it like a labeled box. You put something inside, give it a name, and refer to it by that name later. In Python, creating a variable is incredibly simple. You write the name, then an equal sign, then the value. That's it. Python automatically works out what type of data you are storing. The first type is a string. Anytime you store words, sentences, or letters, that is a string. You always wrap strings in quotes. The second type is integer. These are whole numbers, no decimal point. Positive or negative, doesn't matter. Age, scores, counts, these are usually integers. The third type is float. These are numbers with a decimal point. Prices, measurements, percentages, anything that needs precision beyond a whole number. And the fourth is Boolean. This is the simplest type of all. It can only ever be true or false. Capital T, capital F. You'll use booleans constantly when your code needs to make decisions. Like, is it student? True. Now, and if you ever need to check what type of variable is, use the type function. Pass it the variable, and the Python tells you exactly what you are working with. Now that we can store data, let's teach our program to make decisions. This is where programming starts to feel like real intelligence. We use what's called a conditional statement, built with the keywords if, elif, and else. Here's how to think about it. If this condition is true, do this. Otherwise, check the next condition. And if nothing matched, do this final thing instead. So, look at this example. We have a variable called scores set to 75. Now, we check. If the score is 90 or above, print grade A. But this score is 75. So that's false. We skip it. Python then checks elif score is 80 or above, still false. Then elif score is 70 or above, that is true. So it prints grade C and stops there. You see? 3 critical things to remember. First, every condition line must end with a colon. Second, the code that runs must be indented, pushed in with 4 spaces. This is how Python knows which code belongs to which condition. Third, Python checks conditions from top to bottom and runs the first one that is true, then stops. The else block at the bottom is your catch-all. if none of the conditions above matched, else always runs. Next, we are going to be looking at loops. Loops is one of the most powerful tools in programming. Here is the problem loops solve. Imagine you need to print the numbers 1 to 1000. Would you write 1000 print statements? Of course not. Loops let you write the instruction once and repeat it as many times as you need. This is called iteration in programming. So the first type of loop is the for loop. Now, a for loop goes through a sequence, like a range of numbers or a list, and runs your code once for each item. For example, here is a range of 5 generates the numbers 0, 1, 2, 3, 4. So this loop runs 5 times, each time storing the current number in the variable I, and we print it each time. So the second type is the while loop. A while loop keeps running as long as a condition is true. This one starts count at 1, prints it, adds 1, and repeats until count is no longer less than or equal 5. Now, the range function is very flexible. Range of 5 gives you 0 to 4. Range of 1 to 6 gives you 1 to 5. Range of 0 to 10 with a step of 2 gives you every even number. And two special keywords. Break exits the loop immediately. Continue skips the current cycle and jumps straight to the next one. The key thing to remember, loops saves you from repetition. If you are writing the same code more than twice, a loop is probably the answer. So far, each variable has held one piece of data. But what if you want to store a collection of items? That's what lists are for. A list is an ordered collection of items all stored in one variable. You create it with a square bracket and separate the items with commas. So, for example, these fruits, apples, bananas, and cherry. You see how it's written? Here is what we have, a list of 3 fruits. Now, how do we assess items? By their index, their position number. And here is the catch. Python starts counting at 0, not 1. So fruits at index 0 is apple. Fruits at index 1 is banana. If you use a negative index, fruits at index -1, Python counts from the end, giving you the last item, which is cherry. So lists come with powerful built-in methods. Append adds an item to the end. Inserts puts an item at any position. Remove deletes a specific value. Pop removes the last item and returns it. Sort arranges everything in order. And len, short for length, tells you how many items are in the list. And here is one of Python's most elegant features, the list comprehension. In one line, you can create a brand new list based on an existing one. This line says, for every number x in the range of 5, calculate x squared and put all the results in a new list. The output is 0, 1, 4, 9, 16. Powerful and concise. Our next data structure is one you'll use constantly in real projects, the dictionary. Think of a Python dictionary exactly like a real dictionary. In a real dictionary, you look up a word and you get its definition. In Python, you look up a key and you get its value. Every entry in a dictionary is a pair, which is a key and a value. Here, we create a dictionary called person. The keys are name, age, and city. The values are Alice, 30, and Nairobi. We use curly braces to create a dictionary, and each pair is separated by a column. To access a value, you write the dictionary's name, then the key in square brackets. So person, square brackets, name gives us Alice. Or we can use the .get method, which is safer because it won't crash if the key doesn't exist. Adding a new key is just as simple. Person, square bracket, email equals the email address, and it's added. Updating an existing value is the same syntax. So the three most powerful dictionary methods are .keys, which gives you all the keys, .values, all the values, and .item, which gives you both together as pairs, perfect for looping through. So this loop here goes through every key value pair and prints them both. That's how you read our entire dictionary. Now, we arrive at one of the most important concepts in all of programming, and that is functions. A function is a named reusable block of code that does a specific job. Instead of writing the same code over and over again, you write it once inside a function, and then we call it by name whenever we need it. This is called the dry principle. Don't repeat yourself. Here is the simplest function. The keyword def tells Python we are defining a function. Then the name, we are defining greet. Then the empty brackets means there is no inputs needed. Then a colon. And the indented code below it is the function body. And this is what the code does. To run it, we just write the name followed by brackets. For example, greet followed by brackets. Python jumps to the function, runs the code, and comes back, and we can call it as many times as we want. Functions become much more powerful when we add parameters like inputs. Here, name is a parameter. When we call greet with Alice in brackets, Alice gets passed in as the name, and we see hello Alice. Functions can also calculate something and send a result back using the return keyword. Our add function takes two numbers, adds them, and returns the result. We store that result in a variable called result. And here is a neat feature. Default parameters. If you don't pass a greeting, Python uses hello as the default, but if you do pass one, it uses yours instead. Here is something that makes Python extraordinary. You don't have to build everything yourself. Python comes with hundreds of built-in modules, pre-written collections of functions you can just plug into your code instantly, and thousands more are available for free online. This ecosystem is one of the main reasons Python dominates so many fields. Now, let's look at some built-in functions that you will constantly use, like the math module, which gives you mathematical functions like square root, the values of pi, sailing, flow. You access it by writing import math at the top, then math.whatever function you need, like math.flow, for example. The random module lets you generate random numbers, and it is perfect for games, simulations, or anything that needs unpredictability. And the date time module gives you the current date and time. One line, and you know exactly when your program ran. Now, third-party libraries take things even further. These are installed separately using a tool called pip. And pip is a Python package manager. You open your terminal and type pip install and the name of whatever thing that you want to install. Pandas is for data analysis. Think of it as Excel, but with the full power of Python. NumPy handles complex mathematical and arrays. Requests lets your Python talk to the internet. Flask and Django are for building websites and web apps. Matplotlib creates charts and graphs, and many more. Now, installing is one-liner. Pip install, like pip install pandas, and this is going to install pandas in your machine. Then at the top of your file, you import it. The convention with the pandas is to import it as PD, a short alias. With NumPy, you import it as NP, and you'll see this pattern everywhere. So before you write any code, you write import pandas as PD. We are almost at the finish line, and before we wrap it up, I want to give you something that most beginner tutorials skip: how to write Python the right way. Well, anyone can write code that works, but professional programmers write code that works and is readable, maintainable, and clean. First, let's follow the PEP 8, which is the Python official style guide. Always use 4 spaces for indentation. That is the first rule. Use descriptive variable names. Write user underscore age. Keep lines under 79 characters. And these rules make your code look professional and readable by others. Second, write comments. Not comments that repeats what the code does, but comments that explain why you made a decision. And it is going to help you in future when you need to go back to that code and understand it. Third, keep your functions small. One function should do exactly one job. If your function is doing 3 things, break it into 3 functions. Now the fourth one is don't repeat yourself. That is the dry principle. If you've written the same code in 2 different places, that's a sign it should be in a function. Alright? The fifth is handle errors. Use try except blocks so your program doesn't crash on unexpected input. A good program anticipates failure. The sixth is you test your code. Run it. Try to break it. Give it bad inputs. Fix it. This is how every real programmer works. Trial and error. Alright? And for what's next, the path forward is wide open. Web development with Flask or Django, data science with Pandas and NumPy, machine learning with a lot of stuff, APIs and automation. Python is your foundation for all of it. And that brings us to the end of our Python beginner's guide. I want us to take a moment to appreciate how much ground we just covered together. You now know how to set up Python and choose a code editor. You can write programs using print and understand how Python runs code. You understand variables and the 4 core data types of variables, that is strings, integers, floats, and booleans. You can write conditional statements that make decisions. You can use for and while loops to repeat tasks efficiently. You can store data in lists, sets, and dictionaries. You can write functions that organize and reuse your code. You now know how to handle errors gracefully and work with files. And you've seen how to import modules and libraries to extend Python's power. That is a complete foundation, and that is real programming knowledge. The next step is simple. Practice. Even 20 to 30 minutes of coding every single day will transform your skills faster than you expect. And that is very true. Build small projects, a calculator, a quiz, a to-do list, and each of these always teaches you something new. Thank you so much for joining this session. If you have some questions, drop them in the comments or chat, and I'll answer every single one. Python is a journey, and you've just taken the most important step. You started. Happy coding, everyone. See you in the next one.